Hello and welcome to Algebra I Lesson 17. In this video, we're going to learn about equations of a line. So as we continue in this chapter on linear equations in two variables, we're going to now see that there are ways to manipulate a linear equation in two variables, and each form of the line has a specific use. So kind of the most immediate would be slope-intercept form. And this form of the line is very, very useful to us. When we look at something in slope-intercept form, we know the slope and the y-intercept, and that's why it's called slope-intercept form. So if I have a linear equation in two variables and I solve it for y, meaning y is on one side of the equation by itself like we have here, then I immediately know that m, the coefficient of x, is the slope. This is the slope. And you'll recall that in the last lesson, when I taught you the slope formula, I denoted slope using m. So it's no coincidence that we put m here next to x because, again, m stands for slope. Then plus b. Now, this part right here is denoting our y-intercept. So this is your y-intercept. And that's going to occur at 0, b. So whatever b is, that's the coordinate for your y-intercept, right? That's the y part of it. You'll have 0 always as the x-coordinate when you're looking at your y-intercept, and then b will be the y-coordinate for your y-intercept. So as a quick example, let me just give you a generic linear equation in two variables. Let's say I had something like 4x plus 2y equals negative 10. Really, really simple. So if I want to get y by itself, if I want to solve it for y like I have up here, the first thing I need to do is just isolate this term 2y. So I would subtract 4x away from each side of the equation. And so this would go away. And on the left, I'd have just 2y. On the right, I'd have negative 4x minus 10. Now, to isolate y, to get it in this format, I would just divide both sides of the equation by 2. So I would divide this side by 2. And a lot of students will just do this. They'll divide this by 2. But remember, when you have division like this, you're allowed to break it up and say, okay, I'm dividing this part by 2 and this part by 2. Right? It's like having a common denominator. So you can do it that way. It makes it a little easier to simplify. So this cancels with this, and I'll just have y. And then negative 4 divided by 2 is negative 2. So let's write that as negative 2. And then negative 10 divided by 2 is negative 5. So kind of looking up here, I have y equals m, the slope, times x plus b, which is our y-intercept. So y equals negative 2x. So in this case, negative 2 is the slope. This is your slope, or your m. And then minus 5. So minus 5, you can think of as plus negative 5. So your y-intercept would occur at 0, negative 5. This is your y-intercept. All right, so let's take a look at kind of an official example. And the reason for this example is I want to just convey to you in the past, or kind of, we'll just think about it in our last lesson, we had to do a lot of work to find slope. You know, if we're given an equation, we had to calculate 2 points, then go through and plug them into the slope formula, and then now all we have to do is solve for y. Much, much easier. But I'm going to show you the difference between kind of the old way and the new way. So we have our equation 5x minus 4y equals negative 20. So old way, I'd go through and get 2 points. So let's say I look for the y-intercept. So that's me plugging in a 0 for x. So I'd have 5 times 0 minus 4y equals negative 20. So this would go away, and I'd have negative 4y equals negative 20. A lot of you can just look at that and say, okay, I know the answer is 5. But we'll officially say, okay, divide by negative 4 on each side. This cancels with this, and you'll get y is equal to 5. So if x is 0, y is 5. Okay. Now let's go ahead and use the x-intercept. So that means y would be 0. So I'd have 5x is equal to negative 20, right? Because if I plug in a 0 there, negative 4 times 0 would just be 0. So that would just go away. So for this, I would just solve by dividing both sides by 5. So then x would equal negative 4. Okay, very, very simple. So now I have 2 points. So one point is 0, 5. And the other is negative 4, 0. But now I need to plug these into the slope formula. So remember m, which is the slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so let's label this one as x sub 1, y sub 1. Let's label this one as x sub 2, y sub 2. And let's see what happens when we plug in. So for y sub 2, I have a 0, so plug that in. For y sub 1, I have a 5, so plug that in. For x sub 2, I have a negative 4, so plug that in. And for x sub 1, I have a 0, so plug that in. So 0 minus 5 is negative 5 over negative 4 minus 0, which is negative 4. So you get negative 5 over negative 4, which is 5/4. So that is your slope. And let's write that right here, that m equals 5/4. Now I'm going to show you something in two different ways. I mean, first off, you saw how long and how complicated that process was just to figure out the slope. I mean, it's probably a minute, minute and a half, 2 minutes almost, just to go through and get the first piece of information. Then you got to go back and plug it into the slope formula and get that. So it's very, very time consuming. Let's erase this real quick. I'm going to show you a few different things. So the first thing I just want to show you, and this is just kind of a side note, if you know the y-intercept, which we figured that out, it occurred at 0, 5, and you know the slope, you can write the equation in slope-intercept form. You have all the information you need. It's y equals m the slope, which is 5/4, times x, plus, it's the y coordinate from the y-intercept, so plus 5. And you'll hear that they just say this is the y-intercept. This is your y-intercept, and then this is the slope. Now, I'm going to show you that I can take this equation right here and transform it into this one. All I need to do is some basic algebra. So we have 5x minus 4y is equal to negative 20. Let me scroll down a little bit just to get some room going. So again, if I want to isolate y, the first thing I need to do is isolate the negative 4y. Right? I'm going to isolate that whole term first. And to do that, I would just subtract 5x away from both sides of the equation. Nice and simple. So that's gone. We'll have negative 4y is equal to negative 5x minus 20. The next thing I want to do is get y by itself. So I'm going to divide by negative 4, divide over here by negative 4, and divide over here by negative 4. So what are we going to have? Let's scroll down. This will cancel with this, and I'll have y is equal to, negative over negative is positive, so that's 5/4, then times x. And then you can think of this as plus negative 20, so let's put a plus here. Negative 20 over negative 4 is 5. So what did we end up with? We end up with y equals 5/4 x plus 5. And that is exactly what we had up here, just by the given information, right? Y equals 5/4 x plus 5. So if you have a linear equation in two variables, you can solve it for y, and you can immediately figure out the slope and the y-intercept without going through getting points and then plugging into the slope formula and, so on and so forth. The other thing is, if you're given the y-intercept and you're given the slope, you can just write the equation, right? Again, we're going to do that here in a little while. All right, so here's another example. We have x plus 2y equals 16. And we don't need to go through any tedious process here. We're just going to solve this for y, and we're going to figure out what our slope is. And we're also going to know what our y-intercept will be. So to solve for y, I would subtract x away from each side, right? Because I want to isolate this guy right here. So I would have 2y is equal to negative x plus 16. And then I would divide each side of the equation by 2. So what would I have? That would cancel. I'd have y is equal to, you think about negative x as negative 1 times x, right? We don't typically write that, but to make it clear, you have negative 1/2 times x there. So negative 1/2 times x plus 16 over 2 is 8. So I have my equation solved for y, and now I know that the slope, or m, is negative 1/2, and I know that the y-intercept will occur at 0, 8. So here's another very common textbook type example, something you'll probably get on your test. So we want to write the slope-intercept form of each line given the slope and y-intercept. And we just did this a little while ago. So we have that m equals 9, and again, m is standing for slope. So the slope is 9, and the y-intercept is given as the point 0, 4. So how do I write the equation? I have y equals mx plus b. If you have a problem like that, just write that formula out to begin with. You need to memorize it. Y equals mx plus b. And then just duplicate it. So I have y equals, I know what m is, that's 9, then times x, then plus b. And again, what is b? It's the y-coordinate when we think about the y-intercept. So the y-intercept occurs at 0, 4, so we just put plus 4. So y equals 9x plus 4. All right, so the next one I'm given is a slope, m equals -7/2. Y-intercept occurs at 0, -5. So again, start out by writing that generic formula, which is y equals mx plus b, and just plug in. So y equals, my m is -7/2, so -7/2 times x, and then plus b. So in this case, your b is going to be -5. So I'm going to put -5. You could also put plus -5. Either way, it's the same. You end up with y equals -7/2 x minus 5. All right, what about if m is equal to 5/3? Okay, so a slope of 5/3, and a y-intercept that occurs at 0, -4. So again, write your generic formula. Y equals mx plus b. So y equals, what's m? That's 5/3. So 5/3 times x, and then your b here is going to be -4. So again, you can put -4, you can put plus -4, doesn't matter. So I'm just going to put -4. So y equals 5/3 x minus 4. All right, so we're going to kind of wrap up talking about slope-intercept form with this last point. So a very useful application of slope-intercept form is graphing. This is probably the quickest way to graph a linear equation in two variables. So if we'd have had this, a few lessons ago when we first started talking about it, you'd be like, man, this is really easy. So if you have something in slope-intercept form, you automatically have the slope and you have a point on the line. You have the y-intercept. So it's super, super easy to graph it. So if I have y equals -1/4 x minus 3, I know that the slope m is equal to -1/4, and I know that the y-intercept is going to occur at 0, -3. So to graph this equation, I have that point on the line 0, -3. That's where I'm going to start. Again, that's my y-intercept, so that's going to be right here. And again, the slope, m, is -1/4. Now recall when we first started talking about slope, we referred to it as rise over run. So this equals -1/4, or you could also think about it as 1/-4. These are the same. Remember, if I have a negative divided by a positive or a positive divided by a negative, net in the end, it's a negative, right? So you can write that either way. So starting from this point, I can fall 1 and go over 4, right? That's rise over run. So if I rise -1, I'm falling 1. If I run 4, I'm going to the right 4. So I'm going 1, 2, 3, 4. So this would be the next point on the line. And I'll do that again. Fall 1 over 1, 2, 3, 4. And you can get some points over here too by kind of reversing that and saying, okay, I can also rise 1 and go to the left 4, right? If I have -4 in the position of run, that means I'm going to the left 4. So 1, 2, 3, 4. Do that again. Up 1, over to the left. 1, 2, 3, 4. So there are some points, and we just draw a line through them to graph it. Okay, so now we'll put some arrows at each end. And so this is the equation. Y is equal to -1/4 x minus 3. And let's test some of these points, just in case you don't believe me. So let's test this point right here, which is 4, -4. So we will go back up here, and what I'm going to do is I'm going to test the point 4, -4. Let's see if that's a solution to this equation. So y in this case is -4, so -4 is equal to -1/4 times +4 minus 3. Let's see if each side is equal to the other. So this would cancel with this, leaving me with -1 minus 3. -1 minus 3 is -4. You get -4 equals -4. So yeah, that works out. All right, so let's try this other one now. We have y equals 3x minus 3. So again, it's in slope-intercept form, and we know that the slope, m, is equal to 3. Right? This is our slope. And then we know that the y-intercept occurs. The y-intercept occurs at 0, negative 3. Again, super easy to graph this. So our y-intercept is the same as in the last problem. It occurs at 0, negative 3. So let's go there. And then our slope was positive 3. So the rise over run here, remember, 3 can be written as a fraction as 3 over 1. So what that's telling me is that I rise 3 and I go to the right 1. So I start here. I go up 1, 2, 3 to the right 1. That's a point. Rise 1, 2, 3 over to the right 1. Rise 1, 2, 3 over to the right 1. You could also think about this as negative 3 over negative 1. Negative over negative is positive, so these two are the same. So I could start here and fall 3, 1, 2, 3, go to the left 1, go to the left 1. And if I start from here and follow the original one, go up 1, 2, 3 to the right 1, I'm back on the line. So let's graph this guy. Again, this is y equals 3x minus 3. All right, so the next thing we're going to talk about is called point-slope form. So this is another thing you talk a lot about in class, and it comes from the slope formula. So you have that m, the slope, is equal to y minus y sub 1 over x minus x sub 1. Now, there's a little bit of a difference from the slope formula that you're used to. You're used to seeing y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, let me explain why there's a difference. So in a linear equation in two variables, when you normally encounter it, you don't have a given x or a y. You don't know what those are. You have something like 5x plus 2y equals 7. So these variables here represent unknowns. When we use the slope formula like this, we have 2 points that we're given in most situations. In some, that's not the case, but in most situations, we're given 2 points, and we plug the given values in, right? We plug in the y sub 2, we plug in the y sub 1, we plug in the x sub 2, we plug in the x sub 1, and we do some general arithmetic, and we pop out a slope. Well, with point-slope form, what happens is I have a known point. So one known point, and I know the slope. And the slope is known. So this right here, this x and this y that don't have any other notation, that represents the regular x and y that we're thinking of where we don't know what they are. This x sub 1 and this y sub 1, that's what you're plugging in for with your values from the known point. Okay, so you're using point-slope form when you have one known point and the slope. And you're going to see some examples where it's not exactly like this, but in most cases, you have a known point and you know the slope. So what does point-slope form look like? Well, we just take and multiply both sides of the equation by this quantity x minus x sub 1. So I'll multiply this over here. And what's going to happen is this is going to cancel with this, right? It's the same thing divided by itself. So that's going to cancel out. And it's going to be over here, x minus x sub 1. Remember to use parentheses. So I can erase this at this point. Now it looks a little different in your textbook. In your textbook, it's going to look like this. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. And you can write it like that. It doesn't matter. I can take this and move it over to the left and take this and move it over to the right. I can put the m out in front. Really, all they did was just rewrite it. Nothing is different, right? So you need to realize that immediately. So that's where point-slope form comes from. So once you memorize this kind of generic formula here, you're basically ready to go. So let's look at an example. So we have a point and we know the slope. So we're going to use our point-slope formula. So we have through the point negative 4 comma 1 with a slope of negative 1. So if I have my point-slope formula, y minus y sub 1 is equal to m times the quantity x minus x sub 1. This known point, we label that as x sub 1, y sub 1. So I'm just plugging in. So I have y minus, my y sub 1 is 1, equals, my m is negative 1, times the quantity x minus x sub 1, we know that's negative 4. Minus the negative 4 is plus 4. And so once you have this, this is point slope form. In every situation, they're going to want you to solve it for y and put it in slope-intercept form. If the book says write it in point slope form, you've done that. This is point slope form. So you would be done, right? Because you've mirrored this right here. That's the same. Right? I've plugged in for m, I've plugged in for x sub 1, and I've plugged in for y sub 1. So I've done my job. But in most cases, they want you to solve it for y and put it in slope-intercept form. So let's go ahead and do that. So kind of continuing here, I would have y minus 1 is equal to negative 1 times x is just negative x. Negative 1 times 4 is just minus 4. And I would add 1 to both sides of the equation. So that would cancel. And I would have y is equal to, I'll have negative x. Negative 4 plus 1 is negative 3, so minus 3. And this is slope-intercept form. This is slope-intercept form. I know my slope. It's negative 1, right? If I have a negative out in front of x, that's the same as negative 1. And my y-intercept occurs at 0, negative 3. So that's slope-intercept form. All right, so what if we have one that's through the point 5, negative 1, and the slope is given to us as negative 3/5. So again, I would label this as x sub 1, y sub 1. And my generic point slope formula is y minus y sub 1 is equal to m times the quantity x minus x sub 1. Again, especially when you first start out and you don't know this by heart, write it out so you don't make a simple mistake. And then you just plug in. It's very, very easy. So for y sub 1, I have negative 1. So I can just erase this and put minus the negative 1 is the same as plus 1. For m, I have negative 3/5, so negative 3/5. And then we have x minus x sub 1. So for x sub 1, I have 5. So this is point slope form. Again, if your book asks for that, you could stop there. But in most situations, they want you to solve for y and put it in slope-intercept form. So we would continue simplifying. So y plus 1 equals negative 3/5 times x is negative 3/5 x. And then negative 3/5 times negative 5. You think about that separately over here. This would cancel with this, and I'd have 1. So basically, negative 3 times negative 1 is positive 3. So positive 3 or plus 3 here. And so now all I have to do is subtract 1 away from each side so that y can be by itself. So I would have y is equal to negative 3/5 x. 3 minus 1 is 2, so plus 2. And again, this is in slope-intercept form. I know that my slope is negative 3/5, and we were told that in the beginning. And my y-intercept occurs at 0, 2. 0, 2. All right, so a little bit later on in this kind of section where you're talking about equations of a line, they're going to throw kind of a wrench in your plans. So you'll see this randomly, and you'll be given 2 points, and they'll say, go ahead and write the equation of this line in point-slope form and also in slope-intercept form. Now, if I'm just given 2 points, how am I going to do that? Well, remember, to use point-slope form, I need 1 point, and I need the slope. So I have 2 points, right? I have more than I need in terms of points, but I don't know what the slope is. So how would you suggest we get the slope? Remember, if I have 2 points, I can generate the slope using the slope formula. So this is something you kind of have to figure out, because a lot of textbooks just leave it out. They throw the problem in there, and they want you to do some critical thinking. So essentially what you're going to do is calculate your slope. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then go back through, again, any one can be x sub 2. And this could be y sub 2. And then this is going to be x sub 1. And this will be y sub 1. And we just plug in. So y sub 2 is negative 4. So negative 4. And y sub 1 is 3. X sub 2 is negative 4 also. And then x sub 1 is 1. So negative 4 minus 3 is negative 7. Negative 4 minus 1 is negative 5. So negative 7 over negative 5 is 7/5. So I have my slope now. So m is 7/5. So once I've figured that out, I have all the information to write an equation in point-slope form. I have 1 point, and I have a slope. But some of you will get confused now because you have 2 points to choose from. And you'll say, well, which point do I need to use for point slope form? Well, the answer is whichever one you want. It doesn't matter. And I'm going to do it using both points just to show you that. So let's start out by using this one and saying this is x sub 1, y sub 1. And the point slope formula is y minus y sub 1 is equal to m times the quantity x minus x sub 1. Now, I will plug in a negative 4 for y sub 1. I will plug in a negative 4 for x sub 1. So let's simplify this. So we'll have y plus 4, right? Minus the negative 4 is plus 4, equals, for m, remember that's 7/5, times the quantity x minus a negative 4. So that's plus 4. All right, so then we'd have y plus 4 is equal to 7/5 times x plus 7/5 times 4. 4 times 7 is 28, so this would be 28/5. So now continuing, I would subtract 4 away from each side of the equation. And I'm going to go ahead and write 4 as 20/5. So we have a common denominator there. So that's gone. And I'm going to have y is equal to 7/5 x plus 28 minus 20 is 8 over the denominator of 5. So y equals 7/5 x plus 8/5. So again, this is slope-intercept form. I have my slope, which is 7/5. I have my y-intercept that occurs at 0, 8/5. Very, very easy. Now, I want to show you, using the other point, I get the same answer in the end. So now let's say I had chosen to use this as my point. So this is x sub 1, y sub 1. So I'm just plugging in. So for y sub 1, I'm plugging in a 3. For x sub 1, I'm plugging in a 1. So let's crank this out. So I'd have y minus y sub 1 is 3 equals m, which we know is 7/5, times the quantity x minus 1. So at this point, when we have it in point slope form, it looks a little different. You might say, oh, well, that's not the same. But when you solve it for y, you're going to get the same thing. So you'd have y minus 3 is equal to 7/5 times x is just 7/5 x, minus 7/5 times 1 is just 7/5. So I would add 3 to both sides of the equation. I'm going to go ahead and write 3 as 15/5. So I have a common denominator. So that's gone. Y is equal to 7/5 x. So we have negative 7 plus 15. What is that? That's 8, right? So plus 8 over that common denominator of 5. So we get the exact same thing. Y equals 7/5 x plus 8/5. So that is using a different point, right? So as long as that point is on that line, you're good to go. You can use whatever point you'd like as long as you know the slope. So if you have one point on the line and the slope, you're going to use point slope formula. If you have 2 points and you're not given a slope, you're going to use point slope formula. Just in that particular case, you got to do a little extra work, right? You got to take the 2 points, generate a slope, okay, using the slope formula, then go back and plug in using one of the points. It doesn't matter which one. So go back and plug into the point slope formula that you have, and then you can solve it for y and get it in slope-intercept form. All right, so lastly, we want to discuss something known as standard form. So the definition for standard form, I'm going to tell you this right off the bat, is going to vary between textbooks. So I'm going to give you a generic definition, and then I'm going to give you the one that you're probably going to get when you're in high school. So for standard form, kind of starting out, I would say in college algebra, you'd say ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. So a, b, and c can be anything you want. They can be negative, they can be fractions, they can be anything you want. Doesn't matter. Now, there's a stricter version of this, which you're probably going to be yelling at the screen going, that's not what my teacher said. No, it's got to be interesting. So let me show you that one. So the stricter version, the one that you generally learn in an Algebra I or Algebra II class in high school, will be this. ax plus by equals c, where a, b, and c are integers, a and b are not both 0, and they also want a to be 0 or positive, right? It's greater than or equal to 0 as another condition for a. So with this definition, you generally have a little bit more work to do, but it's all about manipulating the equation. You can kind of do whatever you need to do to fulfill this definition. So let's look at some quick examples here. So again, write the standard form of the equation of the line. We're going to use that stricter definition here because most of you are in high school and you kind of need to know how to manipulate the equation. If you're watching this and you're in a higher level mathematics class and it doesn't matter, then you kind of just get to practice anyway on how to manipulate an equation. So again, we want a to be greater than or equal to 0. That's the coefficient of x. And we want a, b, and c to be integers. We know that a and b can't both be 0, and so it looks like this. ax plus by equals c. So how would I get y equals negative 3x minus 6 to look like that? Well, I'd start by adding 3x to both sides of the equation. And I'd have 3x plus y is equal to negative 6. So at this point, I'm actually done. I've satisfied all the requirements. A and b are not both 0. None of them are 0. A, b, and c are all integers. 3 is an integer. This you can think of as 1. So that's an integer. And negative 6 is an integer. And a is greater than or equal to 0. A is the coefficient on x. So we've satisfied our requirement. Very, very easy. All I had to do was add 3x to both sides of the equation. That's kind of an easier example. What if I got something like this? 0.2y equals 0.8x minus 5. Again, the format I want is ax plus by equals c. A is greater than or equal to 0. A, b, and c are all integers. And a and b are not both 0. So again, the first thing I'm going to do is subtract 0.8x from both sides of the equation. So I'd have negative 0.8x and then plus 0.2y is equal to negative 5. Now, I have two problems here. I have the problem that this is negative, and I have the problem that it's a decimal. So I can fix both of them relatively easily. To convert this from a decimal to a whole number or to an integer, I would need to multiply by the appropriate power of 10. So in each case, we have one decimal place. So all I would have to do is multiply both sides of the equation by 10. Very, very easy. So if I do that, so 10 times negative 0.8x, essentially I'm just moving this one place to the right, the decimal point. So this would end up being negative 8x. Then plus 10 times 0.2y. Again, I'm just moving this one place to the right. So this would be 2y. And this equals 10 times negative 5 is negative 50. So I've solved the part where I want integers, but a is not greater than or equal to 0. Right now I have a negative there. So how can I fix that? Well, I can multiply both sides of the equation by negative 1. So if I multiply by negative 1, negative 1 times negative 8x is 8x. Negative 1 times 2y is minus 2y. And negative 1 times negative 50 is positive 50. So now this is in standard form, in the stricter form of standard form, where the coefficient of x is actually positive. So we have 8x minus 2y equals 50. So a, b, and c are all integers. A is greater than or equal to 0, and a and b are not 0. So all of the conditions are met. Now, some of you are going to say, hey, you could have done that in one step. I could have multiplied up here by negative 10, and I would have got this right away. Well, yes, I could have done that, but I wanted to make it a little easier for you to understand what we were doing, so I did it in 2 steps. But kind of moving forward, if you're looking to save time, that's one of the things you might consider. All right, let's take a look at another one. So we have y equals 1/5 x plus 5. So again, I'm looking for ax plus by equals c. And again, I want a to be greater than or equal to 0. I want a, b, and c to be integers. And I want a and b to not both be 0. I'm going to start out by subtracting 1/5 x away from both sides of the equation. So I'd have y minus 1/5 x is equal to 5. Right? And I just subtracted 1/5 x away from here. That would make it cancel. I subtract away from here. I have it over here. In this particular case, let's think about this. Let's think about doing it in one step. I have the fact that this is negative. Right? I have a negative coefficient for x. I don't want that. Right? A has to specifically be greater than or equal to 0. And I have a fraction. Right? So I don't want that either. I want an integer. So what can I multiply 1/5 by to make it a whole number. I can multiply by 5. Right? If I multiply 5 by 1/5, I get 1. Right? Multiply a number by its reciprocal, you get 1. Additionally, if I threw in the fact that I multiplied by -5, I would change the sign here because right now we have a -1/5. So if I multiply -1/5 by -5, I solve both my problems there. Again, to make that legal though, I've got to do it by both sides of the equation. So multiply over here by -5 and also over here by -5. -5 times y is -5y. -5 times -1/5 x is going to be plus x. You can put plus 1x if you want. It doesn't really matter. And this is going to equal 5 times -5, which is -25. Now you might say, well, this doesn't look like that. All you have to do is switch the order here. Remember, addition is commutative. So I could rewrite this as x minus 5y is equal to -25. And I've written this in standard form using the stricter definition, right? My a term here is 1, so it's greater than or equal to 0. My b term is -5. My c term is -25. So a, b, and c are integers. A is greater than or equal to 0. And a and b are not both 0, right? Neither of them are 0.